Let's do some calculus. Today's going to look a little different than other days. So I'm doing daily lessons 122 and 123, but these are actually all practice problems. So nothing is new today, and I actually put all the answers down already. So if you haven't tried this already, go do this now. I'm just going to provide a brief explanation about each one. So if you have a question after that, please contact me, because these are really important questions for you to know. Also, these are calculator active questions, which means you're going to want to use your calculator on many of them. Make sure that you ask me if there's anything that you don't understand on your calculator. So let's do this. In the first one, all you're doing is checking your answers. So again, if you don't have this done, shut off this video now, come back to it. On this one, it's asking, where does f of x have a relative maximum? Maximums occur when the derivative changes from positive to negative, or f of x changes from increasing to decreasing. So what you do here, you're given a graph of f prime, just graph that, and you're going to look for the zeros. So this place is x is equal to 4.818. That's what or 810, sorry, I couldn't read my own writing for a second. Make sure you do this to 3 decimal places. Even though this last one is a 0, still write it, because afterwards this decimal continues. So always 3 places after the decimal is what you need in your final answer. So you can see my explanation, compare it with yours, see how you did. This says justify your answers, so make sure you do that. Relative minimums occur when the derivative is changing from negative to positive. So in this one, a relative minimum occurs, and we're doing the same one up here. Also, my drawing kind of stunk in the first one, because this would be like here. Sorry, my bad. But you can see it down here, and that's at x equals 0.27. You didn't get the same thing? Ask me, or try yours again and see, do you know how to do it now that you can see the answer? Point of inflections. Point of inflection occurs when the original function, whatever that is, changes concavity. That's really hard to just see where that is on the graph. Lucky for us, in this one, we were given f prime. So to start out, you can do one of two things. You could have taken f double prime, found the derivative, just be really careful, make sure you know the chain rule in here. But you could do it that way and then see where is f double prime changing signs. The other thing you could have done is you could have seen where f prime had a relative min or max. And then you should have been able to see it x equals 1 either way. So it's a slightly different way of doing it, but either way is totally fine. How many relative minimums do we have? So again, we've got a graph of g prime here. If we went relative minimums occur when g prime changes from negative to positive. Think about g changing from decreasing to increasing. So you're looking on the graph of g prime, and then I'm just finding where does g prime change from negative to positive. Make sense? Hoping so. You should be stopping this video a whole lot if you're not already. Okay, this page you don't actually need a calculator, you just need to be able to think through these. So on the first one, there's a lot of important information. One, g prime of a function, g is continuous and it has exactly 2 zeros. So that's nice. So there could be continuous, doesn't mean that g prime is always going to exist, because there could be sharp turns, but continuous just means like, yes, it's defined for all values. The function is defined, the limit from the left equals the limit from the right for all points, and the function value is equal to the limit. So no holes, no vertical asymptotes, anything like that. There could be sharp turns. Selected values of g prime are given in the table above. If g is the set of all real numbers, then g is decreasing on what of the following intervals? If g is increasing, what I'm looking for is where g prime is negative. And so in here you need to be thinking about, okay, g prime has exactly 2 zeros. The function, the derivative of g, we see this, g is continuous and it has exactly 2 zeros. The way this is written, it kind of looks like g has 2 zeros, but it actually is g prime has exactly 2 zeros, which is nice because when I'm trying to find a chart or make a chart for g prime, and so I can figure out mins and maxes for g, what I do on those ones is that I set g prime equal to 0, or I see where it does not exist. So here, if I know I only have 2 values of 0, or 2 zeros for g prime, that allows me to make my chart. I can go negative infinity to negative 2, negative 2 to 2, 2 to infinity. These numbers are all just extra. This tells us between negative infinity and negative 2, at negative 4 and negative 3, I get positive values. So I know g of x is increasing. Over here, this should be, by the way, this should be a g. It kind of looks funny. G is increasing, G is decreasing, because I can see the values between negative 2 and 2. For G prime are negative. From 2 to infinity, G prime is positive, so G is increasing. So the only interval where G is decreasing would be from negative 2 to 2. In the next one. Okay, so this one I'm given f double prime, and we've got this function and a graph over here. So it's nice, I've got both. F double prime is shown to the right. Find the values where f prime has a relative maximum. The way that you should be thinking about this, or should have thought about this, but now maybe you're correcting yourself, or you're like, yeah, that's what I did, and then we like give a virtual high five or an asymptotic high five. That's for you. F prime has a relative maximum when f double prime changes from positive to negative. Think about it, f double prime is the slope of f prime. So you're looking on here, positive to negative, which the only place that's happening when you're reading from left to right would be at A. The next one people get confused on, but not you, because you're going to be like, oh, I understand what this means now. If h of x is twice differentiable, 1, it also means that it's continuous, but h of x is less than 0 for all values of x. Then at what values does the graph have, g of x have a relative maximum? G has a relative maximum when g prime changes from positive to negative. But this little tidbit of information is really helpful because g prime is 9 minus x squared, that quantity, times h of x. When I'm trying to figure out the sign changes, I know h of x is always negative. So really what I'm looking at is, what is this one, positive or negative, times a negative. So on here, I'm going to be saying, okay, well, where are the places where the derivative is equal to 0 so I can even make my chart? Well, h of x is always less than 0, so I'm not going to say that's going to be 0 anywhere. 9 minus x squared, that's what I have to equal to 0. Or I guess I could say does not exist also, but none of these are going to not exist because h of x is always less than 0 and 9 minus x squared is a parabola, which does exist all the time. Then I go down here and I make my chart and I say, okay, well, I know this part of the function, the 9 minus x squared, has zeros at negative 3 and 3, so I can make my chart. And then I figure out, is this g prime going to be positive or negative? Well, 9 minus something in that interval, so you choose your favorite number. Maybe it's negative 10. Negative 10 squared is 100, 9 minus 100 is going to be negative. But remember, h of x is always negative. Negative times a negative is a positive. This isn't like an eye, like a sleepy guy with a funny looking nose. This is negative times a negative is positive. G prime is positive. Same idea here, and here you're substituting a value from negative 3 to 3, 3 to infinity, realizing that h of x is always negative. So I get positive times negative, negative here, negative times a negative is positive here. And that's where I get that the only relative maximum happens at x equals negative 3. That's where g prime is changing from positive to negative. Last one. This one I think is kind of the most involved to think through. Always these ones that are like 1, 1, 2, 1, 2, and 3. I think these are always the most challenging to think through. Okay, we have a twice differentiable function. That means it's also continuous. I can take the derivative twice, the first and the second derivative. And it's over here to the right, so this is f of x. Which of the following statements is true if f of x has only 1, 0? So 1, 0 meaning there's nothing crazy going on. If I have 10, 8, 2, negative 13, the first thing that I can see is just that this 0, do you see how 2 to negative 13? If I only have 1, 0, it has to be in between this interval from 1 to 3. So this one's definitely true already because 1, 0, this is positive, f of x is positive, and then f of x is negative. It has to go through 0. This is part of the intermediate value theorem if a function is continuous, and f of c is between f of a and f of b. This would be 2 and negative 13. This is where it is. 0 is in between those values. Then c is between 1 and 3. So really, a lot of this is just like straight up intermediate value theorem. So that's definitely 2. The 1 and the 3 are a little bit harder. This says f prime is less than 0 on this interval. So what I'm going to look at is just what is the slope. So if I'm saying here a slope from 10 to 8, I actually am going to do y2 minus y1 over x2 minus x1. If you do that, 8 minus 10 is negative 2 over negative 1 minus a negative 3 would be 2. Negative 2 over positive 2 is negative 1. Do the same thing here and here, where I'm choosing y2 minus y1 over x2 minus x1, and I'm going to get the negative 7.5. I can see that f prime is negative every time. Or I could have said f of x is decreasing, therefore f prime is less than 0. Okay, in the next one, f double prime is greater than 0. Let's think about this. F double prime is greater than 0 would mean f prime is increasing. And really, this is why it was helpful, because I could have just said, well, f of x was decreasing, so f prime is less than 0. But me doing all this extra work to be convinced that f prime was less than 0 is really helpful right now, because is f prime increasing? No, negative 1 to negative 3 is decreasing, negative 3 to negative 7.5 decreasing. So my answer, 1 and 2 only. As always, thank you for being awesome. Thank you for being you. Let me know if you need anything at all. Thanks for working. I think you're great, and I'm really lucky to be your teacher. Bye!